Welcome to class. I'm Ayorinde, and at the end of today's lesson, you should be able to describe the derived quantities and units. Okay, now let's first start by describing the derived quantity, which is actually the combination which is actually obtained by combining what are fundamental quantities together. Are you getting me? The same thing with the derived units. They are simply obtained by combination of what basic units. Are you getting what we are trying to say? And a good example of this is density, that is normally obtained by the combination of mass and volume. So the formula for finding density is what? Mass over volume. Are you getting it? Now mass is fundamental quantity, while volume is another derived quantity that can still be calculated. And the formula for finding volume, at least you can still remember this from your junior secondary school class, that volume is what? Length times breadth times height. Okay, and all this length, breadth and height, they are fundamental quantity that is placed under what? Length generally. Okay, now the unit of this density, that is the SI unit, can be calculated based on the fundamental quantities that are combined to make the density. So mass is kg, okay, and the length, breadth and height will be what? Meter cube, and that's why we have it as kg per meter cube. Okay, now let's also talk about another one, which is acceleration. It's another derived quantity, okay, which can be calculated by combining velocity and time, that is velocity over time. Now time is a fundamental quantity, while velocity is not a fundamental quantity. It's a derived quantity, and it can still be calculated, okay, as what? Displacement over time, that is velocity. Okay, and and by combining these formulas together, okay, we can also derive the unit, the SI unit, which is what? Meter per second squared. Okay, and it can be written in its index form as what? Meter seconds raised to power minus 2. Okay, now let's go to the next page to explain this better. Let's use this table to explain more derived quantities and their units. Okay, and the first one we're going to be talking about is area. From your junior secondary school, you know that the formula for finding area is what? Your length, okay, times what? Times breadth. Okay, and all these two all fall into the fundamental quantity length. So the unit is going to be meter times meter, which is what? Meter squared. Okay, now let's talk about another one, of course, which is speed and velocity. Now speed and velocity have the same unit, although one speed only have magnitude, it has no direction, which is scalar quantity, while velocity has what? Velocity has both magnitude and direction. That's why we call it vector quantity. But they have they have the same unit. So the formula for finding speed actually is what? Distance, okay, over time. Are you getting what we are trying to establish? Okay, and the unit is what? Meter per seconds. Distance is meter, while time is seconds. Or you can write it as what? Meter seconds raised power minus 1, using the what? Using the index form. And velocity, the same thing, is displacement. Okay, we call it displacement. Are you getting what we are trying to establish? All over time. Are you getting it? Okay, now, and they still have the same unit, which is what? Meter per seconds. Okay, now let's talk about another one, which is what? Acceleration. We've talked about acceleration the other time as changing velocity over time, and the SI unit is what? Meter per second squared. Okay, now let's talk about another derived quantity, which is force. Now force is mass, okay, times acceleration, and you know the unit of mass is what? Kg. Okay, and that of acceleration is what? Meter per second squared. Okay, and that is why the person that worked on it, the SI unit now is now being named. This SI unit is named after the person that actually worked on force, which is what? Newton. Are you getting what we are trying to establish? Okay, now let's talk about another one, which is what? Pressure. Pressure is in calculating pressure, we say pressure is what? Force over area, just like stress. Okay, force over area, and that will be Newton over per meter squared. Okay, and the person that worked on it is Pascal. So the SI unit now is now referred to as Pascal, which is Newton per meter squared. And of course, the last one we are going to be talking about is power. Now, power is the rate of doing work, which is what? Work over time. Okay, and the work and energy have the same energy, which is joules, okay, or Newton per meter. That's why you have Newton per meter. I beg your pardon, Newton meter per seconds or joules per seconds, and the person that work on it is referred to as watt. So it's same thing as watt. All this unit, one Newton meter per second is the same thing as 1 watt. Okay, and with this we have actually come to the end of this class. See you in the next class as we talk more on physics.